In this lesson, we're going to compare multiplication and division. Very specifically, we're going to compare their properties, and we're going to see how multiplication is just repeated addition and division is just repeated subtraction. Now, because multiplication and division are formed from different operations, their properties are also going to be very different. Let's start by investigating multiplication first. Every property we know about expanding or factorizing, they all come from three basic properties about multiplication. Now, the first rule of multiplication I want to cover comes from the fact that we can multiply numbers in any order. Now, the immediate example I want to give you is the fact that 3 times 4 is the same thing as 4 times 3. This is not really that obvious if you think about it for a moment. On the left, we're saying that we're taking 3 times 4, so that's 3 groups of 4. And then on the right, we're saying we're taking 4 groups of 3. Now, for this simple example, this is pretty straightforward. You can just add them up yourself. 4 plus 4 plus 4 is 12, and 3 plus 3 plus 3 plus 3, that's also 12. But what if this number over here was a really big number, and this number over here was a really big number? How do you know this is always going to work? Now, explaining this to you is not really all that hard. All I really need to do is to draw up a rectangle with 3 blocks on one side and 4 blocks on the other side. To explain why we can actually multiply in any order, I want you to notice that if we count in rows, we're going 4 plus 4 plus 4. And then, if we count in columns, we have 3 plus 3 plus 3 plus 3. In either case, we're counting the same blocks, and we should get to the same number every time. Okay, so in math speak, we would say that multiplication is an operator. If you can swap the two things on either side of the operator, we would call that operator commutative. And I hope you see why this argument would keep working, no matter how many rows or how many columns you have in your particular example. So this property is pretty straightforward, but multiplication has other properties as well. The next property we actually call distributivity. So let me give you an example of it. Okay, so for the next property, I've drawn another rectangle that has 3 rows and 6 columns. To show you the next property, what I'm going to do is I'm going to slice this rectangle like this. Okay, so because 4 plus 2 is the exact same thing as 6, we could just glue these two back together and you just end up with a block that's again 3 by 6. So therefore we can also say that 3 times 6 is the same thing as 3 times 4 plus 2. Because after all, 4 plus 2 is the same thing as 6. But then we also notice something else. The total area of this whole shape over here is just found by adding the area of this shape to the area of this shape as well. Now the shape on the left has 3 rows and 4 columns. And then the shape on the right has 3 rows and 2 columns. So this shape over here is 3 times 4, and this shape over here is 3 times 2. Now in math speak, we say that the fact that you can glue this shape to this shape over here is called distributivity, because you can sort of distribute this 3 to the 4 and the 2. Okay, so now that we know that multiplication is commutative and distributive, it also has one other really important property as well. Let me just show you that one too. Now the last rule I want to show you is the fact that you can multiply things in any order that you like. So for example, if you're doing 2 times 3 times 4, you can do the 2 times 3 first and then multiply by 4. Or you can do the 3 times 4 first and then multiply by 2. Now this rule can also be proven with a really simple picture, but the picture is going to have to be 3-dimensional since you're doing 2 multiplications. So let me start by drawing a 2 by 3 block first. Now on the left I drew a 2 by 3 block because the first thing we did is we multiplied 2 by 3. Now because on the right we're going to multiply 3 by 4 first, I'm going to draw another block on the right that's also 3 by 4. Okay, so let's focus on the left again. We said that we wanted 2 by 3 4 times, so I'm going to need to make 4 copies of this 2 by 3 block. Now since each of these blocks is 3 blocks wide and 2 blocks high, and there's 4 groups of them, then in total we have 24 blocks. I've just drawn the front one in a different color so that you can easily identify which way we counted. Well, as you can probably already see, it's also possible to count upwards as well. So when we did 3 times 4, we could also stack 2 of these on top of each other, and we would still end up with the exact same shape. So let me do that as well. Now the mathematical name for this is called associativity. It basically says that you can bracket things however you like and evaluate them, and you should always get the same answer. In this case, 24. Now, despite the fact that multiplication has all of these nice properties, as you continue your study of maths, you're going to meet a lot of other operators that don't behave nearly as nicely as multiplication. In the future, you're going to meet some operators that are, for example, associative and distributive, but they're not commutative. You'll even meet some that are commutative but not distributive. And really the list could go on. There are so many possibilities. So at the beginning of this lesson, I promised to talk to you about division, and it turns out that division doesn't have any of these properties, at least not in the way you'd expect. Now before we examine whether division is commutative, distributive, and associative, we should first ask the question of what is division and how exactly does it work? So to properly explain division, I've tried to give you a really simple example here. We're saying 12 divided by 4. This obelus over here is the division symbol, and it usually denotes division. Now usually, when people think of division, they think of 12 items like this, and then this 4 over here signifies something like 4 people. So it's almost like you're taking 12 items and figuring out how many each of these 4 people get. And in this case, you'd say that the answer is just 3. Despite this, I think that there's a much more useful way to think about division, and that's through this idea of repeated subtraction. If you're dividing 12 by 4, you're really asking, how many times can I take 4 away from 12? Now, in this case, if we started with 12 items, we can subtract 4 from it exactly 3 times. Now, because 12 minus 4 minus 4 minus 4 is 0, we can say that 12 divided by 4 is exactly the same thing as these 3 rows. Now, it turns out that this is a really useful way of thinking about division, because it answers a whole bunch of questions that you might have had about division. For example, why can't we divide 12 by 0? Well, the reason is because you're going to just subtract 0 from 12 a whole bunch of times. And the point is that no matter how many times you subtract 0, you're never going to make it down to 0. And that's why dividing by 0 just makes no sense at all. But we can say quite a few things about division. The first is that division is not associative. Let me give you an example. Okay, so to show you that it's not associative, let's consider 12 divided by 4. Well, that's the same thing as 3. And then if we go ahead and divide 3 by 2, that's just the same thing as 3 on 2. After this, we can also say that 4 divided by 2 is also 2. And then 12 divided by 2, well, that's the same thing as 6. So because 3 on 2 is not the same thing as 6, we can say that the left-hand side is not equal to the right-hand side. And therefore, you can't just re-bracket things however you like, because it will change the answer. Now, the next rule is actually pretty obvious here. We can say that 3 divided by 4 is definitely not the same thing as 4 divided by 3. Because after all, 3 divided by 4 is 3/4, and 4 divided by 3 is 1 1/3, so they can't be the same thing. Now the next thing I want to show you is that division is not distributive as well. If we look at this term on the left, we can see that 4 plus 3 is the same thing as 7, and then on the left we just have 12 divided by 7. But then on the right we notice that we have 12 divided by 4, which is the same thing as 3. And then we also have 12 divided by 3, which is the same thing as 4. 3 plus 4 is the same thing as 7. Now on the left we notice that we get 12 divided by 7, and on the right we just get the number 7. So this immediately tells us that we cannot distribute division over addition. But there is actually something else I can show you. So let me write down one more example, and we'll look at it as well. Okay, so let's look at this last case together. I want you to notice that 12 plus 6 is the same thing as 18. And then 18 divided by 3 is the exact same thing as the number 6. After this, we can also say that 12 divided by 3 is the same thing as the number 4. And then 6 divided by 3 is the same thing as the number 2. If we just add 4 and 2, we also get 6. So this is actually pretty weird. And it shows us why we treat division a little bit differently to the way we treat basically everything else. If we try distributing from the left, we notice that everything just breaks. But if we try distributing from the right, it turns out that you can actually distribute division from the right. So division is technically not left distributive, but it is right distributive. Now, I hope you can agree that these properties absolutely suck, and you definitely don't want to be dealing with division if you can't do any of these things with it. So instead, as you continue your studies of mathematics, you'll notice very quickly that we completely ban this sign. You're not going to see it anywhere. So the general advice I'm going to give you here is that we're going to completely ban a divided by b written like this. Instead, what we're going to plan to do is we're going to continually write a over b, or we're going to write a times b reciprocal, because again, if you're multiplying, you have all of these nice properties that you can use. So for example, if you're writing ab reciprocal, it's perfectly okay to write this as b reciprocal times a. That's exactly the same thing. And now I guess we should just summarize everything we've said. In this lesson, we talked about the fact that multiplication is commutative, because you can count in rows or you can count in columns. We also said that it's distributive, because you can also cut it into two parts and then you can add up both of these areas individually. Finally, we said that multiplication is also associative, because you can count in this direction or you can count up, and in either case this means that you can put brackets anywhere and multiply in any order and you'll always get the exact same answer. On the other hand, however, division has almost none of these properties. Division is much less convenient to deal with. It's not associative, it's not commutative, and it's not left distributive. But, as one redeeming quality, you can actually distribute from the right. And therefore, we say that you should never write a divided by b using this obelisk over here. Try to avoid this symbol as much as you can. Instead, you should stick to the much more sane things, which are to write a divided by b, or to write a times b reciprocal. My personal favorite is always to write a times b reciprocal wherever I can. The last thing we said was that instead of thinking as 12 divided by 4 as how many items you would give to 4 people, instead you could think of it as how many times you could repeatedly subtract 4 from 12, and the answer in either case is going to be 3. But given all of this information, we've just about completed everything I wanted to say about repeated addition and subtraction. Thanks for watching another Trina video. If you want to say thanks, you got to show your friends. Or maybe you should just visit us at trina.org, where you can track your progress and have access to questions and heaps of other awesome stuff. Or maybe you should just like and subscribe. That works too. But either way, I'll see you next time.